Hi, it's Jan Beta, and in this episode I want to take a first look at something that is completely new to me as well as to this channel, the MSX line of computers. Namely this Philips VG-8010 from 1985. The MSX computers are pretty interesting historically because they were a collaboration between several different manufacturers of electronics, including Philips, Sony, Panasonic, Hitachi made some, and they all came up with a computer architecture that they would build machines for. The collaboration also included Microsoft. That's why these machines run Microsoft BASIC, which most 8-bit computers of the era do. The whole thing started sometime in the 80s, and there were several models from numerous manufacturers. And as I said, they pretty much all share a similar, if not the same, architecture. Ideally, it would be the same architecture, but there are some slight variations. They all use a Z80 processor. They use a common Texas Instruments graphics IC. They use the same AY sound chip, and they all have similar cartridge ports. They are under this flap here. So the software for these MSX systems should be compatible between systems, even if they are from a different manufacturer, which was kind of a new approach to the whole thing, considering that at the time there were mostly separate systems which weren't compatible at all, even if they used similar architectures like the 6502 processor, for example, in the Ataris, in the Commodores and in the Apple IIs. And these were pretty successful in Japan and parts of Europe. They were not that successful in the United States for some reason. There were also MSX2 systems around, which had a couple of improvements, better graphics chips, and I think more RAM as a standard. That varied from system to system. This one claims it has 48K of RAM, but really it just has 32K of RAM plus 16K of video RAM, which isn't really usable by the processor. So yeah, bit of false advertising on here. But this is 32K RAM MSX1 machine. There were MSX2s and there are also MSX2 Pluses, which improved on the architecture slightly. As you can see, my VG-8010, which is the second MSX computer that Philips made, works completely and fully, and it is in good as new, near mint condition. I got it complete in box, even came with the manual. This is the German version of that. The original power supply is also here. And I have the box, which doesn't look that nice. I'm going to show that later, I guess. But the computer itself seems to work fine. Not much to do on this repair-wise, but there's some stuff I want to take a look at today. The VG-8010 actually was Philips' second attempt to build an MSX computer. The VG-8000 wasn't that successful. It basically used the same case and the same keyboard and things like that, but it wasn't fully compatible with the MSX standard. I don't know why they got that wrong, because the standard probably was laid out at that point. But for some reason, the 8000 model was not fully compatible. This one allegedly is. So the only problem we are going to run into when we're trying to run software is the lack of RAM. Some MSX1s have 64K of RAM, and actually it became kind of a standard for the MSX series later on. So some newer games won't run. Some of the old ones only use 16K of RAM, so they should run fine. And some homebrews only use 16K or a little bit above that. This has 32K, as I said, so we're going to be able to run some software on this, I guess. This ended up in my possession by accident, so to say. I was looking for a particular Philips monitor that I had back in the day, and I used it with my Commodore 64, my first computer that I owned myself. So when I did the video series about recreating my original Commodore 64 setup, I looked at eBay auctions and things like that. And the only eBay auction at the time that had one of the monitors I had back in the day was one which the main attraction was this MSX, and the monitor was kind of a gimmick for the auction. So I bid on it, and it wasn't really expensive. I don't know what I paid. I don't quite remember because it's been a couple of years. I think something like 50 euros or something, which is a steal for the monitor and a working MSX system. And then I kind of completely forgot about this, and just recently I stumbled upon this again, sitting in its original box, and I wanted to try it out. So I made a crude monitor cable. Here's my monitor cable, which I made from an old audio cable. This is just composite out. The French version of this, which is black on this part, that's how you can tell them apart, has an RGB out actually. This one has an RF out and a composite out, which is not very good, as you've probably seen on the screen here. But still, we get a picture out of this, color picture, full color. Actually, the pinouts for the connectors are in the manual. So I looked at this, and as you can see, there's a pinout for the RGB version, which this doesn't use, and a pinout for the PAL version, the regular PAL version for the rest of Europe outside France, which has composite out. And it's just an 8-pin round DIN connector, not the horseshoe-shaped one like the C64 uses, but a circular one. So that's the one you need. And I just basically soldered the composite video, which is pin 5, to one of the signal lines, and both grounds on my audio cable together to pin 2, and pin 3 to another signal line, and that's my sound output. So that works with every standard composite monitor that I've tried, so that's quite good. And as was pretty much standard back in the day, the user manual is super concise, and we have an introduction to BASIC, we have memory maps of the system, we have all the functions, we even have the character set back in here printed out. We have, as I said, the pinouts for the connectors. We have some technical intricacies and keyboard layouts, things like that. Super nice manual, as with almost all 8-bit computers back in the 80s. And just in case you want your own PCBs made, I highly recommend checking out the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. You just send them your Gerber files for your specific PCB, and they are going to make it without any problems in a variety of colors, and there's a lot of options that you can choose from. Production times are super fast and delivery is quick, so check out the link in the video description. Back to the MSX. So this video is just going to be kind of an overview, and I'm going to do some smaller things. There's also going to be a full restoration video at some point, basically mostly the electronics, because as you can see, it looks absolutely immaculate from the outside. So no case restoration needed at all on this one. It's a super neat design, I really like that. But the cursor keys, ooh, why? So left is here, right is here, down is here, and up is here. And they actually changed that in the next model, the VG-8010. They have them actually facing the direction where they point. So, and also it's like one of these chiclet keyboards, which is horrible to type on, frankly. And they also changed that in the next incarnation of this system. We have cartridge ports, actually 2 of them. You could run things like, I think, a memory expansion and a game, or another cartridge, software cartridge at the same time. Some of the later MSX models only have 1 cartridge slot, and that's, as far as I've heard, is enough for most stuff. This also has an output for a cassette recorder. This is the power socket. We have a reset button. Yay! We have a pair of joystick ports, actually. These are DE-9 connectors, but they are not quite compatible with, for example, Commodore joysticks. They are compatible for the most part, but not fully. We're going to take a look at that later. This is our monitor output, which has the composite signal, some voltages, and the sound signal on it. And this is our RF out. And that's pretty much all there's to the main system. And then we have the VG-8010 power supply alimentation. This is the power supply for the system. And it provides 5 volts, plus 12 and minus 12 volts. These were made in France, actually. The Philips production was in France at the time. This has a nice clunky on-off switch. It's pretty lightweight, so I wonder if this is a switching power supply. Maybe it is. It should, probably. If it provides 1.55 amps at the 5 volt rail, it would need a really huge transformer if it wasn't a switching power supply. So we're going to take a look at this today. And also because I don't have a suitable tape recorder. I mean, you could use any tape recorder probably with the proper cable, but I didn't make that cable yet. I'm also going to make a little cartridge for the MSX using this PCB that my friend Ollie makes, who most of you probably know as Banjo guy Ollie, who does excellent cover versions of video game tunes on his YouTube channel. And he actually also has a YouTube channel where he tinkers with old systems, the 8-bit Manshed, which I highly recommend too. So I'm going to link those channels in the video description. And Ollie is one of the nicest people in the retro community anyway, so I highly recommend checking out his work. Okay, first things first, I want to take this thing apart. The connector on this actually is a 4-pin DIN, which interestingly has 2 indentations for the direction it plugs in. The pinout is also in the user manual, so you can easily make your own. The user manual is also available online on the MSX wiki, if I'm not mistaken. I'm going to link that in the video description as well. So this should open up quite easily. I think it has 4 screws, if I'm not mistaken. Yep, there we go. Oh, it's upside down! Wow, okay, and this is indeed a very old school switching power supply, it seems. Small transformer, or it's actually, I think, no, it's one transformer in a strange package that I didn't see before, I don't think. These blue ones are Philips brand caps, actually. These other blue ones are Philips brand as well. They don't make capacitors anymore. They have been, the capacitor division at least, was bought out by VG-8010, who make the capacitors now. Which looks similar, but not as shiny. So these are really old school Philips capacitors. And this is a Nippon Chemicon, I think. Yeah, I think it would be a good idea to replace the electrolytic capacitors in this. I think that's going to be the first thing I do. And this is also quite handy because you can unplug this. Yay! That's our on-off switch. We can just unplug that. Then our board is free. And there are some pretty peculiar things about this. Yeah, for one, they used this 2.2 microfarad electrolytic capacitor over this plastic capacitor, or polyester film probably capacitor. That's just soldered onto the legs of the orange capacitor there. And they also used a lot of actual caps actually standing upright in a radial cap position, kind of. That's peculiar. I don't know why they did that. I know that Philips made many actual caps, and in some of these places it makes sense. Oh, there's also a resistor soldered over another resistor there. Or, oh, over a capacitor, probably, judging by the color. Okay, this is some old school stuff, but this is mid-80s, as I said. This machine probably was made in 85. Can't see any conclusive date codes on here, though. And the backside of the board looks super old school as well. But as with all things Philips made, this seems to be pretty well made. So there's a lot of space between the hot side, which has the little thunderbolt symbol on there, because this is the hot side and this is where our DC voltages come out. So no touchy. No, you shouldn't touch any of this really while this is powered on. We should also discharge the large capacitors. Some of those can hold really high voltages and are going to bite you if you don't discharge them. I took a bit of a closer look at this, and it seems like this one is the high voltage one for the switching power supply. That is a 22 microfarad 358 volts capacitor, which is a super uncommon value these days. 22 microfarads is a common value, but usually these capacitors are now 400 volts or 450 volts rated, the ones for switching power supplies. This is the one we want to discharge because this is the high power one. I'm just going to use my screwdriver to discharge this. The other ones are all relatively low voltage, and it seems like they are all standard capacitors, general purpose caps. So I'm going to replace all of these smaller ones and this 4700, I believe, yeah, microfarad one as well. I'm mostly going to use radial capacitors for these positions because, yeah, as you can see, the legs are just bent on these actual capacitors, and it should be super easy to fit radial capacitors in these positions. Yeah, on these there's a ring where the negative side of the capacitor is on these Philips actual capacitors, so I'm going to be careful to not mix up the polarities. Maybe I'm even going to be able to find a proper replacement for this silver one, but for now I'm going to leave it as is. I'm going to replace all the other ones in the hopes that I can clean up the voltages slightly and maybe make the picture quality of the output a bit better. And obviously you could replace this with a modern power supply with these specifications. 5 volts, plus 12 and minus 12 volts are super common voltages these days. As long as you go with something that outputs 1.55 amps on the 5 volt rail and 100 milliamps on the 12 volt rails, you're going to be fine. So probably that would be a better idea, but I'm kind of into using the old stuff as long as it works. I want to take a look at this transistor or voltage regulator thing. It has a kind of clamp that holds it to the heatsink. We're going to have to remove that anyway because, as usual, I want to replace the heatsink compound on there as well. Just click on. There we are. It seems to be a BUX84 made by Philips, PH, probably that means Philips. It appears to be a bipolar NPN 400 volts, 2 amps, 40 watts transistor. So yeah, that's what that is. And you can still get them. Yeah, that's a standard transistor, it seems. Let's do some recapping. I'm going to go one capacitor at a time, and I'm going to make sure I get the values and the polarity correct. I'm going to match the voltage closely. You can go a bit higher voltage-wise, but you want to make sure that the capacitance is the exact same. Ah, I see. We have multiple options here. So there's also a hole in a position that suits a radial cap, so probably they just used what they had at hand for these. Yeah, that fits fine and it connects to the correct spot. Yeah, so I'm just going to do this and stop talking, basically, because it should be relatively straightforward. I don't have an actual replacement for this 22 microfarad 40 volts one, so I'm just bending a pin on a radial one, so we can fit this like so. Hopefully. Like this, I just bent the positive leg, so I made this into an actual capacitor. Unfortunately, I don't have a replacement for this 2.2 microfarad one, 63 volts. The best I have is a radial 50 volt rated one. I won't use that because I don't know which voltage this actually sees. I'm just going to leave this in there, just like the silver one. This seems to be an actual cap as well. The negative leg has been cut off, so the can is the negative. It acts as the negative. Hence this clamp here, I think, which just contacts the can and makes contact to the ground plane. So that explains that. So my next step after recapping the capacitors I have is going to be removing the old thermal compound with a Q-tip and some alcohol and put some new one in there on this transistor. I'm using this vermelite paste, which is a common transistor silicon-based thermal compound. I'm just going to put some on there. And then we're going to put the clip back on. Like that. Okay, that makes a very positive grip on our little transistor there. So it's all back together. Let's put it in the case just for safety and test it. Interestingly, this sits in here at a slight angle. The mains cable that goes here. 4 screws should do the trick. Okay. Yeah, I've connected everything back up and my power supply still works. Wrote a little basic program there. Ah, it has a stop key which just stops the program. How do I actually stop the program? Shift stop? Nope. Oh, there we go. Control stop. We can list this. This is my program. Yeah, as you can maybe see, the picture quality is still not very good. It's still kind of fuzzy, but I think it got a bit better at least. I'm going to leave this running for some time to make sure my power supply works okay. Nothing gets overly hot or anything like that. Seems to be promising so far. No explosions. Yay! And it still works after about an hour of running, and power supply doesn't get overly hot or anything, and the system still works. So I suppose my recapping was a success. Yeah, obviously it would be nice to run something else on this apart from my self-promotion here. So I'm going to build one of these cartridge PCBs. So these little boards are pretty straightforward, really. You put an EPROM socket in there and an electrolytic capacitor, a ceramic capacitor, and you can use some jumpers. I'm going to put pin headers in these positions, but you can also just close the jumper position you need for the type of EPROM you put in this socket, or if you don't want a socket, you can also solder the EPROM directly to the board. I'm not going to do that because I want some choice of EPROMs. I want to be able to replace them and test things out. This supports EPROMs from 27C64 to 27C512, which is 64 kilobytes. For everything else, you need some additional logic for bank switching. So this is a versatile, basic MSX Cartridge PCB that Ollie made. So here's all we need. 100 nanofarad ceramic capacitor, which has 104 on it. It's also written on the board. I have a low profile 100 microfarad capacitor here, which probably fits nicely in here, standing upright. Otherwise you would have to bend it to the side in some way, so you have enough room to insert this. Also some pin headers that are the not the round type of pin, but the square type of pin, so it can fit jumpers like the ones you plug in. And 28-pin socket that you want to put in here in the correct orientation. Let's put it together. And obviously we need an EPROM, but we're going to get to that in a second, or in a couple of seconds. So there we go, that's our cartridge PCB, and now we just need a couple of little jumpers like these to set it up for the EPROM type we are going to use. Speaking of which, we should burn an EPROM. I have my trusty ThinkPad set up here with Windows running. I have my Mini Pro EPROM programmer, and we're going to download a nice game for the MSX that should work on all MSXs that have at least 16 kilobytes of RAM. This game is by Juan J. Martinez, who made very nice games for the Amstrad CPC, for the Commodore 64 and for the MSX, and also for the ZX Spectrum and the PC, I think. So we're going to download Night Night, which is a nice little platform puzzle type of game. So we can download this, and we get a ROM file, which should be a binary file that we can program into an EPROM. The cassette file and also the manual is in here. So let's download that, and I'll be back in a second. So this comes as a zip file. I've already unzipped that, and we have our CAS file, our ROM file, and some pictures and the manual. Let's program the EPROM. I'm starting up my Mini Pro programmer. And this is a 32K file, so we need a 32K EPROM. So here's my assortment of EPROMs, and I have a 27C256, which is a 32 kilobytes EPROM here that I erased previously. I'm going to put that in the programmer and load the ROM file in the software. So obviously we have to select the correct EPROM type, which is an AMD AM27C256, DIP28, and all the settings should be perfect for our purpose here. We can do a blank check, although we have to uncheck the check ID here because these older EPROMs don't even have an ID. And the software complains about that. Let's see if it's blank. Okay. So now we can load our little file here, which is the Night K ROM. And it's a standard binary file, just loading this as is. You can do the same with other cartridge ROMs for the MSX that are available on the internet. So this should be totally programmable now. And we're going to program our EPROM. I actually programmed one off camera previously, Night Night. I made a little label for it. So now it's time to put it in our cartridge. And that should just be a matter of putting it in here in the correct orientation. We have already set this up with the jumpers to the settings according to 27C256, jumper 1, jumper 7, jumper 8, jumper 1, jumper 7, jumper 8. This should now be a game cartridge, ideally. Let's see. And this should go, I think, in slot 1, just like this. And yeah, it fits quite nicely in there, so let's see what it does. Is this going to work, or is it just going to blow up? I hope it works. Let's see. MSX. MSX. It's not working. It just keeps resetting. Did I set the jumpers up correctly? I think so. It just keeps resetting. Something's wrong there. I had to burn another EPROM, this time with Uchusen Gamma, also by Juan. And that's a 27C512 EPROM. It's a larger game. And this one actually runs. I don't know why the other one didn't work, but this one we can just play. It's a nice shoot 'em up. And it totally works. Sound works. Everything seems to work. Not sure why the other one didn't work, but maybe the EPROM was broken, or maybe the game isn't quite compatible with this MSX. I'm not sure. But at least we got this one working just the way I did the other one, just with the larger EPROM and the other file, obviously. You can also download that from Juan's website for free. It's a nice game as well. Yeah, there's only one thing left to do, I guess. Yeah, the last thing I'm going to do today is to make a little joystick adapter. Standard Atari pin-out joysticks, that means they only have one fire button. These two are actually mapped to the same pin on the connector. So the directions and the fire button 1 are the same pin-out like on, for example, the old Atari consoles and the Commodores. So you can use these standard joysticks without any issues on the MSX joystick ports. But there are some slight differences in the pin-out that make it impossible, if not dangerous, to use anything else than these standard joysticks. So here's a little table of joystick pinouts that is available on the individual computers wiki. I'm going to link that in the video description as well. And as you can see, we have our standard Atari joystick. That's what the thing I just showed you is basically. We have up, down, left, right, pedal inputs, one fire button, a voltage supply 5 volts and ground, and some pedal inputs that we are not going to use. Usually for these standard joysticks, the voltage supply isn't used, so that's not going to be connected in all the normal Atari standard joysticks. However, on joysticks that use, for example, an autofire or a slow-mo circuit or something like that, we are going to have the 5-volt pin connected, and also on some joysticks you're gonna have a secondary fire button or a third fire button even. And I'm going to build a little adapter because the pinout for the MSX in this column here, you can see that the VCC goes to a pin that is usually connected to something else. And we also have the button 2 connected to where usually the 5 volts is connected. We have a strobe out and we have the ground on a different pin than usual. So I'm going to make a little adapter. I'm going to take the Amiga standard, which is the same as the Commodore 64 standard. Most joysticks I have are for that standard, so I'm just going to wire this up according to the MSX standard. So connect ground not to pin 8 on one end, but to pin 9. And I'm going to connect the 5 volts to pin 5 on the MSX side. And I'm also going to hook up button 2. I don't have any joystick yet that has button 2 wired up at all, but I'm still going to wire that up accordingly. So that should be pretty straightforward. We just need one male and one female DE-9 connector and a bit of cable and wire this up according to this diagram. So we actually need 8 strands of wire, and the only cable I have that has that is this old network cable that I already cut the connector off. So we are just going to use a piece of that and then wire it up to 2 DE-9 connectors, and the housings that the connectors are going to go in are going to be added. I'm just going to solder this. It should be pretty straightforward. Most of the pins just go straight through. Obviously we don't need a very long cable, but I'm still going to leave myself some room because this is a long cable that is pretty useless because it's a very old network cable. I think I'm going to note down the wiring that I'm going to use, so we're not going to run into any issues with that. And we also have a nice ground cable here that we are not sure. Maybe we're just going to use that for ground, so it's even going to be shielded. Which doesn't really matter if we only use a short cable like this. But yeah, doesn't hurt. So strip the insulation off of all these wires and I'm going to tin each one of them. I think we are not going to use all of them, but I'm still going to tin them all because I'm not sure which color I want to use for which connection yet. Yeah, there we go, all the connections tinned. So now I have my pinouts here, and basically these, this is one male and one female DE-9 connector, and they just match up like this. So pin 1 on the male one is here on the solder side, this end here, and on this female one it's actually here, like on our pinout. Okay, I think I'm going to start with this one. This is the Commodore side of the adapter, and this is going to be the one that plugs into our MSX. So this is marked like this, so it's going to be easier to find pins, and this is the one that takes a bit of thinking. I'm going to note down what we need, the color codings of the connections here on this pinout, and this is the pinout for the MSX. So let's do that, I guess. Pretty confident that I made all the connections in the correct spot, so we're just going to assemble these connectors. We don't need to fit these parts here to screw it down in a connector, because none of the devices we have is going to support that anyway. And that's just going to get into the way. There we go. That should be that. Let's test it. Ha! I ran into a slight issue in that this connector doesn't make it all the way into the socket there, because we have these clamps. So I'm going to have to file those down. I didn't see that coming. Yeah. Yeah, that should be sufficient. So here's my Competition Pro that I repaired. It was completely crumbled. And I used one of those connectors on there too. So that should fit fine. Let's see if our auto fire works. That means that the 5 volts is coming to the correct pin. We're going to see. Fingers crossed. I'm pushing the auto fire. This is auto fire on these triangular buttons here. Yep, that seems to work. See if it works in-game as well. Yep, we indeed have auto fire. And the directions also work, the normal fire also works, so I think my adapter is a success, unlike my playing. Yeah, I think that's enough tinkering for this video. The MSX, my Philips VG-8010, seems to work absolutely no problems whatsoever. The power supply is a bit safer now. My cartridge that I made works fine. My adapter cable that allows me to connect standard Commodore joysticks to this works fine. As I said, there's probably going to be more MSX videos, probably even about this machine or other machines maybe. Thank you very much for your support on Patreon and on the channel memberships page and on Ko-fi and on PayPal and elsewhere. Hope to see you again on this channel sometime. I'm Jan Beta. Thanks for watching. See you next time. Bye.